Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 9, Lesson 3 on cylinders and their volumes. So this is the first time we're going to really be looking at a solid that is not a prism or a pyramid, right? That's basically all you've ever looked at in Math 6 and in Math 7. Today we start to look at cylinders. So let's begin by thinking about a shape that's kind of cylinder-like, but is still a prism. All right, so cylinders are very important solids and they're similar to prisms. So let's review something that is almost like a cylinder, but not quite. Exercise number 1. A right hexagonal prism is shown below. Answer the following questions. The area of its base is 68 square centimeters and its height is 8 centimeters. Letter A, describe all horizontal cross sections of this prism. One is shown. All right, great. So what is going to be true? How can you describe every horizontal slice of this cross section? Pause the video now and write down something for letter A. Well, every horizontal cross section of this right prism, and this is true of all prisms, every horizontal cross section is identical, or, using some good geometry, congruent to the hexagonal base. So all cross sections, all horizontal cross sections, hello red, all horizontal cross sections are identical congruent, let's say, to the bases. All right. So, in other words, it wouldn't matter where I sliced this. As long as I sliced it horizontally, I would see exactly the same slice. Now let's get to something that should be relatively easy. Letter B. What is the volume of this prism? All right, well, we reviewed how to find the volume of a prism in our last lesson. Why don't you pause the video now and figure out the volume of this prism? All right, well, the volume of any prism is simply going to be its base area times its height. Its base area was given as 68 square centimeters. Its height was given as 8 centimeters. And so we can bring our calculator out. 68 times 8 gives us a volume of 544 cubic centimeters. Now, before we move on, again, just a review of why this formula makes sense, right? The base area of 68 square centimeters basically tells me that I could stack 68 cubes on a bottom layer that sit on this base. That 8 centimeters would then tell me that I could get 8 of those 68 layer cubes stacked on top of each other. So this is how many cubes per layer, this is how many layers, this is how many total cubes. But that area of the base, right? The area of the base literally is like, hey, I could stack 68 cubes on this hexagon on the bottom and then 8 layers of them for a total of 544 cubes. Now, let's take a look at what a cylinder is. All right. Prisms have horizontal cross sections that are identical to its bases. Cylinders are very similar solids. So what is a cylinder? A cylinder is a solid with two congruent parallel bases that are circles. And one lateral face, right? That lateral face wraps around those circles. When this lateral face is perpendicular to the circular bases, it's known as a right cylinder. And you see right cylinders all the time. If you take like a soda can, that's more or less a right cylinder. You know, if you see like a barrel of oil or something like that, that's a right cylinder. Oftentimes like oatmeal or other things like that come in right cylinders. And again, you see them all over the place. And it's real simple, right? A circle on the top, a circle on the bottom, and then this sort of like shape that wraps around the outside, this one lateral, right? This one lateral face that wraps around and connects the two circles. So let's take a look at a right circular cylinder in exercise number 2. A right cylinder is shown below whose radius is 5 centimeters and whose height is 12 centimeters. Answer the following questions. Letter A, how is this cylinder similar to the previous prism? Right, so why did we do that problem with the prism? What is kind of similar between a cylinder and a prism? Think about this for a moment. Pause the video now. Well, it's pretty much this simple. A cylinder is like a prism in that every single one of its horizontal cross sections is identical to its circular bases. That's it, right? And really, what is the difference between the hexagon prism that we just saw and the cylinder here? Well, the difference is for a hexagon, right, the base is enclosed by straight line segments. Here, it's enclosed simply by a circular curve. So how is this cylinder similar to the previous prism? Its horizontal cross sections are all identical to its bases. Right? So very, very similar. I mean, imagine that you had a prism, right? That wasn't a hexagon like what we had in the last problem, but maybe had like 20 sides to it. A 20-sided polygon, right? That thing would have so many sides, it would almost start to look like that polygon was a circle itself. One might even think of a circle as being an infinite-sided polygon, right? Tons and tons of sides. Now, pretty simple. Let's take a look at letter B. What is the area of the base of the cylinder to the nearest tenth of a square centimeter? Well, the base is a circle. You know its radius, so why don't you pause the video now and calculate the area of its base? All right, well, the area of the circle, right, is going to be pi r squared. That's going to be pi times 5 squared, or 25 times pi. This is where we need our calculator, definitely. 25 pi. And we're going to get 78.5 square centimeters. All right. Now, our final problem, right? Letter C. What is the volume of the cylinder to the nearest cubic centimeter? Well, now I didn't tell you how to find the volume of a cylinder. So, without a formula, how do you find it? Pause the video now and think about how you might be able to find the volume of a cylinder based on the work from exercise number 1, where you found the volume of a prism. Pause the video now and see if you can figure that out. Well, the volume, right? The volume is still going to be the area of the base times the height. It's going to be 78.5 square centimeters times 12 centimeters. All right. Actually, I'm just going to take this last answer and do times 12. Right? I'm just going to do times 12, and I'm going to get 942.477, etc., which is 942 cubic centimeters. Now, you might say to yourself, wait a second, you know, this is the volume formula for a prism. Why can we use it for a cylinder? Well, keep in mind that really, all that volume formula really for a prism said was you take the base area, which is how many cubes you could sit on top of this base, times the height, which is how many layers of cubes you can stack up, right? And that gives you your volume. Now, the reason that constant cross-section is so important, is think about it. Imagine instead of having a cylinder, maybe you had like a cone. We're going to be dealing with cones in a little while. Not in this lesson, but maybe that's a better cone. Imagine that you had a cone, right? Now, if you started to stack up cubes, the cubes would eventually get outside of the cone, right? Think about that, right? You know, I mean, not ones right in the middle, those might be able to go all the way to the top, but any cubes here would eventually exit the cone, right? But if you have a constant cross section, if the horizontal cross section is always the same, then as you stack cubes up, they won't get outside of the figure until you hit the top base. So as long as you know the area of the base and the height, and the cross section is always the same, then you can find the volume by doing the area of the base times the height. You really shouldn't use a rounded area of the base. You should use, you know, the sort of the more scary decimal looking area of the base that we have sitting right here, but that's easy enough to do. Calculate the area of the base, hit times the height, boom, and you've got the volume of the figure. But that's it, folks. That's how you calculate the volume of a cylinder. It's exactly the same as the volume of a prism. You simply calculate the area of the base, multiply by the height, and you've got the volume of the cylinder. So let's play around with more cylinders and their volumes. Here it is. To find the volume of a prism or cylinder is identical. Identical. Multiply the area of the base by the height of the prism/cylinder. The only question is how you find the area of the base. That's it. Do you find the area of the base by using, you know, the area formula of a rectangle, or the area formula of a triangle, or the area formula of a circle, right? It's still identical. So let's take a look in exercise 3 at another cylinder. The cylinder shown below has a height of 15 inches and a base radius of 10 inches. Letter A, find the area of the base to the nearest tenth of a square inch. And letter B, find the volume to the nearest cubic inch. All right, now normally we just want to be able to find the volumes all at once, but we're going to do it in stages. Let's get the area, then let's get the volume. Pause the video now and find the area of that base, which is a circle with a radius of 10, to the nearest tenth of a square inch. Now, we'll use the more exact area down here when we find the volume, but for right now, find the area for letter A. All right, well, let's do it. Since this is the area of the base, I'm going to keep using that big B for area of base. That's pi times r squared. That's going to be pi times 10 squared. All right, I'll just take it right from there. Pi times 10 squared. Actually, let me clear this out so it's the only thing on the screen. Pi times 10 squared. Or maybe only the 10 is going to be there. One more time, pi times, I might as well just put in the 100 now, but I'm gonna be ordinary about it. So that's gonna be 314.159, etc. So to the nearest tenth will be 314.2 square inches. Okay, all right. Simple enough, right? Now, to find the volume, what we want to do is we want to take our area, use the more sort of like lengthy decimal version down here, and we want to multiply it by that height, and then we're going to round, at least in this problem, to the nearest cubic inch. So pause the video now and find the volume of this cylinder. All right, well, again, the volume is simply going to be the base area times the height. That's going to be that 314.159, etc. Again, always better to use the non-rounded version than the rounded version. The rounded version can introduce errors into your answer that you don't want. Luckily for me, my area is the last thing on my screen, so all I have to do is times 15, and that will take my previous answer and multiply it by 15. That's 4,712.38, etc. And to the nearest cubic inch, 4,712 cubic inches. Again, one of the things that I really love about finding the volume of a cylinder, you know, if that's even an appropriate term, i.e. loving finding a volume, is the fact that it is identical to finding the volume of a prism. And if you understand this idea of just taking the base area and multiplying it by the height, and as long as you can find the area of a circle, then finding the volume of a cylinder is pretty easy. Let's do a little bit more work with it. All right, let's see what we got. Now, the interesting thing about cylinders is, again, they're everywhere, right? And oftentimes they hold liquids, right? They hold, like a soda can, a cup, and in problem number 6, we're going to talk about a water bowl. So let's take a look at that in exercise number 4. Exercise number 4. A water bowl for pets is designed in the shape of a cylinder that has a diameter of 14 inches and a depth of 6 inches as shown. Letter A, what is the area of the base of this water bowl to the nearest tenth of a square inch? All right, so again, we start by just finding that area. All right, why don't you pause the video now and find the area of the base of that cylindrical water bowl. All right, well, we always want to be careful, right? Because what we've been given here is the diameter of the circle that serves as its base, not the radius. So just be careful, that's all. You want to make sure that you use the correct thing, right? The base area will be pi times r squared. That's going to be pi times 7 squared. See if I can have a little bit of an easier time on this one. Let's clear that out. Pi times 7 squared. And that's going to give me 153.9384, etc. And this is to the nearest tenth of a square inch, so we're going to say 153.9 square inches. Ooh, there we go. Barely snuck it in. All right, let's take a look at letter B. The company that sells the water bowl states that it holds 4 gallons of water. If there are 231 cubic inches of water per gallon, evaluate how accurate their claim is. All right, so it would be hard to really create something maybe that holds exactly 4 gallons of water. But given that we know how many cubic inches are in a gallon, 231 cubic inches of water per gallon, all right, I'd like you to assess how accurate their claim is that this bowl holds 4 gallons. Pause the video now and see what you can do. All right, well, let's find the volume, right? The volume is how much water it holds. Now, we know that the volume, right? The volume is going to be the base area times the height. Now, our base area is that 153.9384, etc. Our height is 6, so our volume, we're just going to take our previous answer and multiply it by 6. Our volume is 923 we'll just go 2 units here, 63 cubic inches. All right, 923.63 cubic inches of water that go into this bowl. But we want to see how accurate the people were when they said that it held 4 gallons. In order to do that, we have to use a unit conversion, right? Right here, 231 cubic inches per gallon. It should be simple enough, right? It's like taking the number of eggs we have and dividing it by 12 to figure out how many dozens of eggs we have. So now I'm going to say the volume in gallons, right, is going to be our 923.63 cubic inches divided by 231 cubic inches per gallon. And let's see what we get. How many gallons do we have? I'm going to take my last answer and divide by 231. That's going to give me 3.998, we'll stop there, gallons. Now remember, their claim was that it holds 4 gallons. So hopefully when you look at this number, 3.998, you'd say, that's a very accurate claim, right? I mean, for all intents and purposes, that is 4 gallons, right? If I rounded it to the nearest tenth, it would be 4. If I rounded it to the nearest hundredth, it would be 4. Only if I didn't round it to the nearest thousandth would it not be 4 gallons. So I'm going to claim it's a very accurate claim. Is it exactly right? Well, no, but then again, the 6 inches and the 14 inches aren't exactly right in all likelihood. I mean, they're what we're given, but at the end of the day, the idea that this is exactly 6 inches and exactly 14 inches probably wouldn't be true in the real world, if you just think about it. All right, let's take a look at one final problem. Here we go, exercise number 5. A machine part is made from a cylinder bored out of another cylinder. Bored means taken out. The outer cylinder has a diameter of 7 centimeters, and the inner cylinder a diameter of 5 centimeters. The part has a height of 4.5 centimeters. Find its volume to the nearest cubic centimeter. All right, so this is what we would call a subtractive volume problem. In other words, you've got some large cylinder, and then you've removed volume from that large cylinder by boring out a smaller cylinder. So what you've got left, right, is this kind of ring, if you will, that has a height of 4.5 centimeters. What I'd like you to do is try to figure out its volume. Keep track of your decimal places, keep careful. Remember, we're rounding to the nearest cubic centimeter, so make sure that when you find your two volumes, you at least take them out to a few decimal places farther than a cubic centimeter, right? Don't round to the nearest whole number for your two volumes before you do your subtraction. All right, play around with this a little bit. All right, now this is the first one where we didn't sort of walk you through, first find the area, then multiply it by the height, get the volume. So let's try to do it all together, right? Let's do the volume of the inner, right, the inner cylinder. Now, we need to have the area of its base, which is going to be pi r squared. But its radius is half of the 5, so that's going to be 2.5, right? This is the area of the base. All right, let's talk about this, right? That's just pi times r squared. Since the diameter is 5 centimeters, half of the diameter is 2.5 centimeters. If that's not immediately obvious to you, take the 5 on your calculator, divide it by 2, and get 2.5. Now that's the area of the base, but ultimately I would then take that area, whatever it is, and I would multiply it by the height, which is 4.5 centimeters. All right, so this is just simply my height. So let's do that. Let's do it all at once. We won't even figure out the area first. We'll simply do pi times 2.5 squared. That's the area of the base. I could figure out that right now by hitting enter, but I'm just going to then immediately multiply by 4.5. And I'm going to find that the volume of that inner cylinder, the one that we removed, was 88, and we'll just do 2 decimal places here, 88.36 cubic centimeters. All right, so that's the volume of the cylinder that I'm going to remove, that I'm going to throw away. Let's find the volume of the outer cylinder. That's the bigger one, right? And it's going to look very, very similar because the area of the base is going to be pi. Half of 7 is 3.5. And then I have to multiply by the same height, right? It's also a height of 4.5. Okay, and let's do that all at once. So we're going to get pi times 3.5 squared times 4.5. I don't need the multiplication symbol anywhere here because we're enclosing all those in parentheses. So we get 173.18 cubic centimeters. Now, I've got sort of my overall volume. Let me move this out of the way. Right, that's the 173.18. Then I removed my 88.36. So the volume of the part, which is what I really want, is 173.18 minus 88.36. And that, let's take a look. I'm just going to do subtract, which means my last answer will just be there, 88.36. And we end up with 84.82, etc. But I want it to the nearest cubic centimeter. So that's 85 cubic centimeters. All right, and that's it. All right, a subtractive volume problem where we start with some large volume, we remove some other volume, and we do that mathematically with the process of subtraction. No great surprise. All right, let's wrap this lesson up. Because what did we really see today? Well, we saw what a cylinder was, especially a right circular cylinder, right? A cylinder is just anything that's got, kind of like a prism, two identical circular bases, and then a right circular cylinder is one where those two circular bases then have a perpendicular lateral face that wraps around it. The great thing about cylinders is finding their volume is identical to finding the volume of a prism. We simply calculate the area of the base. Granted, we have to calculate that using pi times the radius squared, and then once we have the area of the base, we then multiply it by the height of the cylinder. This is identical to finding the area of the base of a prism and multiplying by its height to also find the volume. Now, we're going to use the volume of a cylinder in some of our following lessons, but in the next lesson, we're going to then look at the surface area of a cylinder. For now, I want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.